To see and decode the UART or serial data on an oscilloscope, we first need an UART signal. For that, let's grab a breadboard, and for the signal, I will use an Arduino to generate it, as it is very easy to do with the Arduino. I will be using this Arduino Nano. So I will first place the Nano on the breadboard. I chose Arduino because it has an hardware UART built into the microcontroller. So we can code it to output any signal we want, which we will then connect up to the oscilloscope and decode. After connecting the USB cable to the Nano, it's time to look at the code. Arduino coding is done in the Arduino IDE, and the language it is written in is C++. Watch my Arduino basics video if you don't understand anything about this. Moving on to the code, we use the serial.begin function and put 9600 as the baud rate in the setup. Then in the loop, we simply can write serial.write or print with the data in double quotes. Just add some delay so the data pulses. Now we can click upload and the code will be uploaded to the Arduino. The next thing we have to do is set up the oscilloscope for decoding the signal. What we have to do is go into the math section, choose decode 1, and in the decoder select RS232. Then if we select decode, the scope will automatically decode the signal for us. We have to select the baud rate correctly. Now as we selected 9600 in the code, we will also set 9600 here. There are settings for selecting the channel for RX and TX. We can set the channel as channel 1 as we are looking at the signal at that channel. There are many other settings such as order, data bits, stop bit, parity, etc. I will just leave them at default. Then I connected the USB cable to the scope just to provide power to the Arduino. Then I took a male-to-male jumper and connected the probe to it. We don't need to connect the probe ground because the USB connection is already providing the ground connection. Then I connected the jumper to the TX pin on the Arduino. Now all we have to do is put the scope on single shot mode, and there it is. The UART signal captured by the scope and decoded as well. The scope decodes the data we received, and it is the data which we wrote in the code. You may also notice that there are two extra set of data. CR is for carriage return and LF is for new line. Similarly, we can look at much more complicated data from other devices as well. I hope you got to learn something from this video. If so, then do consider giving a like and sharing this video. Thanks for watching.